right. Hello and welcome. My name is Jordan Newton with Sonic Air, and today I'm excited to be talking with Kevin Jeffries. So, Kevin is an environmental health and safety professional with 26 years of combined industry and consulting experience. He has worked with hazardous materials, including combustible dust, for most of his career. And Kevin currently works for DEKRA Services, Inc., as a technical lead, process safety for DEKRA North America. He's certified fire protection specialist and certified fire and explosion investigator as well. Kevin, welcome. Thanks for joining us today.
Thank you, Jordan. Good to be with you.
So, can you tell me a little bit about being a technical lead and what's involved with that, and what you actually do as that technical lead?
Yeah, the primary function is to help the North American division of DEKRA Process Safety develop kind of a centerline approach to our dust hazard analyses, our process hazard analyses, all of our offerings that our clients want to make sure that they are technically sound, that our recommendations are both safe and practical. Also, as technical lead, looking for new offerings and services based on kind of the concept that we use. We want to kind of understand what markets, what potential regulations are coming in the future, and kind of get ahead of the curve and create offerings for clients, and you don't even know that you have that need yet. So we're trying to stay ahead of the safety and risk curve and create solutions for you long term.
I like that. That's fantastic. Okay, so I know you're on the road today. Tell me a little bit about where you are and what's going on.
This week, I'm at the NFPA conference and expo. I had the honor of speaking. The topic was ignition sources, primarily static energy, and
Okay.
ways to mitigate it. The NFPA conference is one of the better conferences on the market right now in terms of fire and risk prevention. So the ASSP is a great one for your basic general safety, but this NFPA conference, if you're really looking for kind of cutting edge technology and solutions and thought leadership on dust hazard mitigation, fire mitigation, it's one of the better conferences.
Excellent. Excellent. All right. So I'm really excited and glad to be talking to you today because I had a friend and kind of a colleague ask me recently. His name's Matt. Matt owns a family business that's been around for probably 50 years, and they do foam and rubber converting and cutting, and they punch holes in foam and things like that, and it makes a little bit of dust. It doesn't make a ton of dust like our typical big dust producers like paper or plastics or wood products that we typically think of in food and grain, where we think of the just tons of layers of dust. But he has a little bit of dust, and he's part of the OSHA voluntary protection program here in the US. And so through one of the inspections that he had recently, the inspector came in and said, "Hey, what are you doing about the dust? I know you've got this kind of a old style collector thing, but let's talk more about that and ways to address that, and tell me what you're doing." And so he called me, and I knew I was going to be talking to you. And so I figured I would let somebody with some certainly more expertise than I have on the subject kind of elaborate and help me guide him on where to start and how to get going, and what to even be looking for or looking at.
The first thing I would recommend is to collect some of the dust and have it tested. Um, there are a couple of pathways that you can take for testing. One is a simple go no go, and that will tell you whether or not the dust is actually combustible. Um, the other testing that he'd want is specific testing for specific hazards. You'd want to know the KST, and that's basically the
Mhm.
strength of the explosion. With that test, you also get the P max, which is the maximum pressure that during the test, the results show the highest pressure rating that the deflagration experiences. The KST and P max values are used in designing protection for dust collection systems. So ideally, if there was enough dust that an OSHA inspector saw accumulation, a central dust collection system is one option. If you go with that larger central dust collection system, it will need protection, and that
Mhm.
KST max value will tell you what type of how to size uh, the protection solution. If it's a case of point generation, so there are points where, particularly you said in the drilling and maybe some of the chopping operations where the
Mhm.
dust is generated, there are portable collection options. The portable collection options, if they're less than 8 cubic feet, don't require protection. And the primary reason that they don't require protection is the engineering community has not found solutions that would adequately protect vessels less than 8 cubic feet.
Okay.
So there are producers on the market. There are several that produce portable collection systems. So you could do a series of smaller systems or look at the larger. But again, the first thing to do is test the dust, understand the properties. There are other test properties you may want. May want the minimum ignition energy, which tells you the lowest temperature at which the dust will react. The lower the MIE, the more reactive the dust. Um, the other tests help you decide if you want to look at other solutions. So if you need to look at some ignition control, if you need to look at maybe some inerting, and for this type of dust that you're talking about, I don't think inerting would be an option, but there are other tests like limiting oxygen concentration. That's the test that you perform to determine if you were going to inert the environment. There's also minimum ignition temperature layer and cloud. So there are a variety of tests, but the first thing to do is confirm that the dust is combustible, and then from there decide on a mitigation pathway.
So, am I right that if he doesn't want to go through all that, he doesn't want to do all the testing, he can treat it as combustible and then just go from there, right?
Well, if he does that, here's the danger in that is now sizing protection for a larger collector
Okay.
without data. And what happens with that is, let's say it's combustible, but it has a lower KST value. That
Hmm.
lower KST value means that in terms of isolation, so if you're protecting a collector, you have to protect the collector either with venting, and ideally you'd put that vent, the dust collector outside, because if you're dealing with a
Right.
rubber dust, the byproducts would be toxic. There are flameless vent options,
Okay.
but and those are if you want to store the collector inside. But the flameless vent options are limited, uh, both in terms of melting dust, which the rubber and plastic dust would be, and even in
Mhm.
terms of toxicity. So in his case, we're talking a dust collector outside, vented. In order to size that vent properly, you need to know those maximum pressures in the KSTs. The other thing is with the isolation. So on the dirty inlet, the air that's going to the collector, if it comes back that it's a lower KST value and you use one of the mechanical isolation devices, that device could potentially be compromised with that lower KST. We have seen where improper placement and sizing of those vessels for lower KST values, the isolation doesn't react in time, and you get pressure buildup
Okay.
in valve press as it goes through the system. So the testing is important for that protection.
Okay, that makes a lot of sense. Now you said 2 key terms here that I want to maybe go back and unpack just a little bit, just in case somebody like my friend Matt is
Okay.
completely new to this space and doesn't understand what we're talking about. You talked about venting
Yes.
and isolation. So can you talk
Yes.
briefly, kind of define those and
Okay.
what's entailed with that and how that works?
So with dust collection systems or protecting any vessel, you have a couple of options. You can try and suppress the explosion or deflagration, or you vent through a designed area. You vent the explosion forces. So that would be the pressure and the fire. Um, like I said, with dust collection systems, you have multiple options. You can suppress or you can vent, right? The suppression options, the challenge there is that if you chemically suppress the system, you have to calculate the operating pressure. So that's whatever pressure is conveying the dust to the collector, deflagration pressure, and the pressure of the discharge canisters. Now
Now
that
when you talk about pressures and pressure buildup, so we're talking about in the event,
Yes.
and I say unlikely, but it probably happens more than we're all comfortable with.
Right.
But we're talking about when a potential spark or something else or something overheats in the system and it's inside the ductwork, inside the collector,
Right.
and now back to the KSTs and the PMAX you're
Yes.
talking about. That's when you're talking about that pressure builds
Pressure.
up.
Right.
And we're trying to alleviate that pressure so it doesn't cause catastrophic damage to the
Exactly.
building and loss of
Right.
life and
That's
that sort
that's
of thing.
that's the goal. And so if you're using the chemical suppression option, you've got to take all those pressures into account. And so that initial
Hmm.
deflagration pressure, operating pressure, plus the uh, suppression pressure of the canister,
Okay.
that's all side that has to be properly calculated, because what can happen is that all of that pressure could blow the dust collector apart, and then you defeat
Right.
the purpose.
Right.
So the venting option, and you've got two options with venting. You've got what I call kind of standard venting, where you've got a membrane or a disc that ruptures, relieves pressure, and allows the flame and smoke and all that to escape. And then you have the flameless vents that I talked about earlier. But
Hmm.
flameless
Hmm.
vents, there are a couple of manufacturers who've done testing and certification to against melting dust, but there are more failures than there are success stories. Like I said, there are only a few manufacturers who have adequately tested against melting dust. But the flameless vent keeps the pressure still released, but the flame is contained. And so if
Okay.
you have a dust collection system inside the building, that's an option. But it cannot be a toxic dust. In other words, the
Okay.
rubber and the plastic, when they burn, there's toxic smoke that comes from that, and you don't want that inside the building. So the option there would
Got
be
it.
a standard venting pressure and everything outside the building to a safe area.
Sure. Sure. All right. So, and the whole key here is when it happens, we do it in a safe and controlled manner.
Safe and control method. And
Okay.
here are a couple of interesting facts. So sometimes you the ignition source is actually just the conveyance of the materials, and that was one of the things I talked
Okay.
about at the NFPA conference. You could have a low minimum ignition energy material, a
Hmm.
bulk solid, that is also insulative, which means the charge as it's conveying, as the particles make contact and separate, that generates enough energy to actually self-ignite the material as it's flowing through your ductwork and into your dust collector. Sometimes
Okay.
the pulsing of the dust collector during
Okay.
cleaning could cause the explosion. So there are, there's I guess the traditional pathway of people thinking that maybe a spark or an ember from a
Hmm.
point
Hmm.
gets to collect and goes to the dust collector. That happens, but there are also instances where, like I said again, an insulating dust, low MIE, just through pulsing, has created issues. Now you have to
Okay.
have the right concentration at the right time of the energy, and all that has to line up. And what happens is it's almost like that, Russian roulette. The recipe is there all the time. It's just that the energy from the spark, the concentration of the cloud, they don't match at the same time. And
Right.
when they do, or if they do, that's where
Hmm.
protection comes into play.
Hmm. And it's like I tell a lot of people when I'm talking to people who are new to the dust industry or new to the dust hazards arena. We're trained as kids to be aware of fire alarms and fire hazards and that sort of thing. And in school, if somebody, there's a fire alarm, we walk in a straight orderly line in a
Right.
neat fashion down the hallway and out the door to the rally point or whatever. But there's no time for that with a dust explosion.
Oh,
Whether it's in a collector or out in the ambient air in your facility,
right.
it's instantaneous. And once
Yes.
it happens, it's too late. The probability and the likelihood that everything happens in that perfect storm that you're talking about is fairly low, but the risk of what happens and the results are just absolutely catastrophic when something like that does happen if you don't have the proper precautions
Right.
in place like you're talking about to mitigate that.
And here's we offer at DEKRA, we offer two approaches to kind of the dust hazard analysis. There's a risk based, and then what we call a traditional or prescriptive DHA. And what you find is that as you dig into the dust hazard analysis, and that's the intent, you actually find that the occurrence of each individual event
Hmm.
may happen at a frequency that the organization is not aware of and they're not comfortable with. So just like the scenario I outlined before, where you could have an insulating material, particle separation creates enough energy. Just simple loading the material into a sifter could cause a fire or flash fire. And the other thing that I want to say before we move forward is uh, the NFPA standards are designed so that you're building safeties to prevent fire, flash fire, and deflagration. So you have to look at all three. So
Yeah.
where you may not have your explosion potential may be low, the fire potential may be high. Your flash fire potential may be high. So you have to look at all areas. And as you said, the flash fires and the deflagration events, they happen in a matter of milliseconds. No
Right.
time to react. So that's why you build in all these safeties. But until you do the deep dive analysis to understand the properties of the material, how the process runs, and how it could potentially you create that perfect storm, until you know where all that is, you're operating at a point where you're going to potentially injure people, you're going to potentially interrupt supply chains, and no organization should be comfortable with either. And so
Right.
and we've gone into places where the belief is that uh, the potential for an explosion was so remote that they originally were not going to move forward with anything. They were just like, well, it's combustible dust, but once we identified just the layer accumulation and how you could have an initial flash fire that would create a pressure wave that would disturb all the secondary dust,
Hmm.
and then the resulting fireball from that flash fire would ignite that and create the secondary deflagration. They saw that domino effect and understood. And the solutions, the challenge is the solutions are not all major capital expenses. Now, there are times where that's going to be necessary,
Sure.
but
Sure.
sometimes the solutions are as simple as going back to the source of generation, maybe even modifying a protocol, whether it's changing how things are mixed or adding point source dust collection. There are a lot of solutions. So you don't, I always tell people, don't go into this thinking that I'm going to have to spend millions and millions on a remedy. Let's first find what the problem is, and then let's develop practical solutions. And that's one of the things that at DEKRA we kind of pride ourselves on is we try to give you as much credit for inherent safeties in the process,
Hmm.
and we
Hmm.
understand where you are in terms of process and business continuity and finance. So the idea is let's find the solution that's going to be safe first, one that you can sustain over the lifetime of your process, and one that is cost effective.
I like that. Safe, sustainable, and affordable.
Yeah.
I think that's a big deal. And I think those are certainly some key elements that need to be in place
Right.
for any organization to adopt something or a change
Right.
that's coming their way.
Right.
And they've got to own it and make it their own.
They have to make it.
Okay, so you touched and you kind of went down the road of the DHA, the dust hazard analysis, a little bit. So is that where I should tell my friend Matt to start
Yeah.
and take a
It,
look at something like
it
that?
first confirm that the dust is combustible in the form that it's generated. Once that happens, then the next phase is the DHA. And the DHA,
Okay.
we've done complex systems where you've got multiple collectors, multiple areas where dust is generated, to some simple systems where there's just some wood grinding or chopping or something like that. So um, that DHA is designed to look at the process and look at the potential for the fuel, of course, because now if we
Hmm.
tested it and we
Hmm.
confirmed it's combustible, we've got the fuel. We're looking for credible ignition sources. Now, the testing, depending on how much testing. So, if we do the testing, we get the MIEs and we get the layer ignition temperatures. That also tells us where we need to focus our efforts in terms of looking at credible ignition sources. So, if the MIE is 500 or greater millijoules, 500 millijoules or greater, that means that the material is difficult to ignite, not impossible, but difficult. At that point, we're looking at uh, mechanical sparks from failures. We're looking at hot spots from friction. We're looking at surface temperatures. Those are the things that we're focused on. Open flames, process conditions. So one of the other things that we look at is there a potential for a runaway reaction that could generate heat that could then be the source of ignition? So we look at that.
Mm-hmm.
Anything less than, generally we say, if you're in that 100 millijoules or less range, we're going to be concerned not only with those higher ignition energies, but also static. So now the bonding, the grounding, all of those things matter. So that MIE test will tell us where we need to focus. So now we're not looking at a wide range of ignition sources. We may be able to narrow that, right? And then we're looking at potential for dispersion. So if there's a potential for dispersion, that means that dust could stir up and get in the air. Then we're going to, look at surfaces. We're going to look at a lot of, variety of ignition sources. If dispersion is not possible, or there are no credible means of dispersion, then we're focused on fire potential, right?
Okay.
And then we'll look at confinement. So if confinement is there, then we have the potential for the explosion, the deflagration. If confinement is not there, then we're looking at flash fire potential, right?
So talk a little bit more about confinement and what that means. We're not talking about, in an industrial setting, sometimes you hear the word confinement and you think confined
Confined
spaces.
space, right,
And
right.
so we're not talking about that.
Well,
Pick that apart a little bit.
what we're talking about in terms of confinement is at the point, like let's say they're drilling the components, and they were to enclose that area where they're drilling, then that's a confined area that if the dust is dispersed, it meets a credible source of ignition. The pressure can't relieve fast enough. You have that compromise of that structure. So confinement, just think about it. Anywhere you've got a point source generation for dust, if there's anything that is covering it, so even with like sifters and things like that, any kind of clamshells or coverings, that's creating a confined environment. And if you have that confined environment and you don't have a relief of the dust concentration, and all you need now is that credible source of ignition, and you've got the combustible dust pentagon.
Sure. And this can even be as big as your four walls on the roof, right?
Yes, exactly, exactly. And that's what happens with the secondary explosions, which usually lead to more of a catastrophic loss of life. The building's not designed to relieve that pressure. Of course, the pressure is going to escape, but it escapes through members that now cause structural failure and collapse.
Yeah, that goes back to the can't run like you can with a fire alarm.
Yeah.
The walls go out, the roof comes down, and it's bad news very quickly.
Right.
Yeah. Okay. So under the DHA, we're looking for fuel, we're looking at ignition, we're looking for dispersion. What else?
Confinement.
Yep.
Right.
Confinement.
Right. And then, of course, in most processes, the oxygen is always going to be present. But as I mentioned before, that limiting oxygen concentration test, that's an environment where you would inert. So a lot of the folks that are in the 3D printing, where they're using the metal additives, that's all done under an inert environment. Because you're using the laser, you've got the combustible metals, you've got all of that stuff there, but you've removed the oxygen. That's the only reason why in that environment you don't have the explosion. But what we're seeing now is that the subsequent dust collection and some of the off-gassing, if that's not properly passivated, we have seen that turn into fire, flash fire, and explosions as well. So the actual process is covered, but some of the dust collection creates an issue.
So 3D printing, a fascinating new technology that's pretty revolutionary, but now there's new hazards associated with that. And so we've got to come up with new solutions and new ways to do that safely.
Yeah.
I love it. That's great. All right. So how does Matt start on a DHA journey?
So on the journey, what contact resources, preferably DEKRA, to find out what their protocols are for collecting samples and sending the dust out for testing. So you want a credible lab, an accredited credible lab to do the testing. DEKRA, before I joined DEKRA, was in industry working for a variety of companies, and I used DEKRA for the bulk of testing for particulate solids. So you send the material off, you get it tested, you get your report. Then based on those results, now you can do two things. You can have the test pathway going, and you can kind of you talk to someone and get a DHA scheduled. The way that happens is, our sales team would work with him on understanding the process, the types of equipment, types of materials, put together a proposal. Based on the proposal would include preparation. So that would include looking at state and local regulations as it relates to dust. Because one of the things you have to remember with this is there's a compliance element and there's a risk element, right? And the two are generally linked, but sometimes not. Sometimes, from a regulatory standpoint, there could be more stringent requirements in a particular area, and sometimes those requirements are based on experiences, other people in the area that may have had an event, and based on that, the local authority said, "I'm not going to allow anyone else to have more than 3 dust collection systems
Mm-hmm.
inside of a building."
Mm-hmm.
And again, they're perfectly within our right to do that, and that's usually justified based on some experience. So what we would do is we'd examine the regulatory impact. So that's looking at state, federal, local. Then we dig into the process itself, looking at actual risk. And there are instances where, from a prescriptive standpoint, there are some requirements that you'd have to satisfy. But one of the things that we try to do is look at performance-based options. So you've got 2 pathways to correction. There's prescriptive, where you just look at the codes and standards and you follow them, to the letter. And then there's performance-based, where you look at calculations, you look at probabilities, you look at some of the science behind what the credible scenarios you've identified. And if you can prove that there are risk mitigation methods that are safety equivalent, but not necessarily the exact things that are mentioned in the standard, you
Mm-hmm.
then go to your local authorities, your local firefighters, your fire marshals, maybe even your insurance company, because they are an authority having jurisdiction because they insure your
Right.
operation. And if you show them your analysis and everybody's on board with it, then you go down that performance-based path. Performance-based is usually more, in terms of pricing. The upfront engineering and analysis is where the cost is, but sometimes that solution long term is less over time. So again, those are the options. So if we're talking about his journey to a DHA and ultimately a list of recommendations, it's the testing, it's talking with the salesperson to get the proposal developed, it's then having the consultant come out to the site, perform the dust hazard analysis, generate the report with findings and observations and recommendations. And then from there, the recommendations are ranked in terms of severity. So there's a high priority, medium, and low. Then all he'd do is take those and start knocking out some of those high priorities. Sometimes the lower priorities or general recommendations are administrative controls that can, soften or reduce the potential for an event to occur until that larger capital could be developed. So that's the general approach. And again, the DHA, what we're finding is that some local authorities have asked, some fire marshals have actually asked for the DHA and what's in the recommendations. The regulatory communities, different things, different states. So you can't. The requirement to have a DHA completed was September 7th of 2020.
Right.
So there are people who met the deadline, and there are some fire officials who are asking, "Let me see it," but we're not seeing that in every state and every jurisdiction.
So you said something I think is very important. You said there's a difference between compliance and safe.
Yeah.
And I think, we see that every day when we get in our car and drive down the road. Putting our seatbelt on is compliance with the law. That's what, the law enforcement's looking for as you pass them. But having airbags, most of the cars we drive today have airbags in them.
Yeah.
That's an extra layer of safety to protect us. And when we think about putting our families in a car, that's something, we may be looking for when we go purchase a new car, is that extra level of safety. And I think when we are in charge of workplace safety, if we're in that position where a plant manager, a production manager, a safety, health and safety manager or advisor, that's what we're looking for. And it shouldn't be just about the minimum we can get by with compliance. That's okay. That's a place to start,
Right.
but that's not always the best practice.
Right.
And so, yeah, you talked about the cost, and I think some people also get concerned about the cost when they think DHA and, oh, I've got to change what I'm doing. Oh, I've got to get a collector or get new suppression or new venting put in the collector or whatever the case may be. I think there's a pathway and a progression. It's not something they should freak out and say, "Oh, I've already spent all my capital budget for this year. I can't do it. I'll have to wait till next year." There's ways to get started on that process now,
Yes.
and then you can budget for that over time. You can present to the authorities. Matt with the VPP process, he can show them what he's working on and where he's going. Right.
Right. That it shows progress over time. And
Mm-hmm.
again, there are again, I'll say our approach to conducting a DHA. Let me give you the example of mixers. Right. Mixers are an inherent hazard in a process.
Mm-hmm.
But depending on the formulation, how you add the solids or any liquids or anything, and the speed of the mixers, you have various degrees. You may actually not have a hazard that needs to be protected versus one. If you just go into it, and this is where screening your consulting resource is important. If you have someone who goes in and just understands the regulations or the code, but they don't understand the background of the regulation and code. So the NFPA standards, and one thing too, I want to the NFPA standards are clear, but what happens is they're not written in a format that everybody's used to seeing in terms of the OSHAs and things. The
Sure.
NFPA actually provides more technical guidance and direction if you go through and you take the time to read the standards. So there's some good guidelines there, but in every one of the standards, it gives you the basis of where that recommendation came from. And if you hire a resource to do a DHA and that resource doesn't understand the science behind the recommendation, and they come in and they see your mixers and say they all need to be protected, and they don't
Mm-hmm.
ask you those critical questions like, talk to me about your production rates here, talk to me about how full the mixer is, talk to me about the tip speeds, then they're not going to do the necessary analysis to determine, well, you got mixers, you got dust collectors, you got sifters. Well, where do I start? If you're not peeling back the layers to look at the total operation, then somebody's going to get this report with all of these recommendations, and it's going to be frustrating. But our
Yeah.
approach is to try and dig down to that level to say, well, you may need to address the mixers, but here's where you've got some mitigating circumstances because we've done the analysis. So the
Mm-hmm.
mixers could be a phase two in the 2023 budget, as long as you're doing these things now, but your priority are, those dust collectors. And in terms
Yeah.
of dust collectors, is dust collector 1, 3, and 7. So we do that deep dive analysis so that when you walk away, if there are some mitigating circumstances and it's like, I can wait until the next budget cycle, or if there's some things where, shut this down, here's some immediate things you need to do. And we've done that. I've been on site where we had to shut down an operation. We had to do some calculations. We had to make some calls. One of the things about the DEKRA network, we've built, a good rapport with a lot of different folks, and we've made calls and kind of taking advantage of those partnerships that we have with people to get
Mm-hmm.
clients back up and running with a mitigating circumstance. One case in particular, client had a standard explosion vent on a dust collector inside the building, which means, and we did the calculation, about a 20 or 30-foot fireball aimed right at packaging employees. Again, not aware that the hazard
Sure.
was there.
Sure.
Shut the process down. It worked with, in terms of their scheduling, all this, but made a call to one of our partners who's in the space of providing flameless vents. They had one on the shelf that met the requirements for the client. Then at that point, we stepped back. Those two developed
Sure.
your mutual agreements and purchase orders. There was one on the truck coming to the client within a week.
Love it.
And so it's that kind of approach. So we're not just going to come in and just say, hey, you got a problem and walk away. We try to partner with you. Our goal is to become that trusted advisor for life. So I don't want people to listen to this and say, I'm going to have to, process modifications may be necessary. Capital investments may be necessary, but until you peel back the layers and do the analysis, you won't know where to go. And our goal is to give you more of a playbook so you know where to budget and put your funds.
And I think that plays into your strength, what you're talking about, that prescriptive analysis. So, it may not require capital expenditure. It may be like you were talking about, slow the mixer down, or, change your ingredients in
Your
your
ingredients.
mix a little bit.
Right.
If that can work for you, that's a way to do it, to mitigate a
Yes.
lot of the risk rather than having to do big capital expenditures
Right.
and that sort of thing.
Right.
So,
And that gets back to, and then that's where we ask the question, can you sustain it? So
mm,
when we conduct a dust hazard analysis, we want more players in the room. The more players in the room, the better. So that's even down
sure.
to your HR representative. We want to understand the total footprint of the operation. Because if we leave the site with an agreement that this is the path forward, and we haven't looked at the R&D pipeline, we haven't looked at the innovation schedules for the next couple of years, what we come to in terms of a basis of safety may change based on what you're planning to do over the next 2 or 3 years.
Hmm.
So that's
Hmm.
another thing that, from the standpoint of our approach, we want to understand the total business. This is not, again, let's come in tunnel vision, let's only look at these factors. We want to understand, again, it's that partnership.
Right.
We want to be the part. We want to understand the total business, total operation, because if we build in, or we don't take into account that you're going to go with a smaller particle size in 2 years and what that means to the operation, we could
Right.
do you a disservice.
Sure. And I've seen that. I've seen a facility that was running a batch of plastic compounding material, and they switched to a smaller particle size from their supplier.
Right.
And it gave them the end product they were looking for, but suddenly they've got tons of leaks in all their ducting and equipment.
Exactly. Yeah.
And their fire marshal came in and said, "You've got a huge combustible dust
Right.
issue."
Right.
And they were able to simply go back to their supplier and say, "Hey, we need to go back to the larger particle
Yeah.
size," and it solved it.
It's all,
So
yeah.
it was an easy fix in a scenario like that.
And
So go
one of the
ahead.
things one of the things with that, and again, as part of our assessment, is looking at management systems. And one of the critical components of a good management system is management of change. So the
Mm,
idea is that before you make that change, you do the technical review and you go back to look. And so in our report, we talk about all the different requirements, and this is, if this, then that, right? So if you go back and you say, well, I'm making a modification, I'm adding a grinder, I'm trying, because in the report we've outlined that particle size was a basis of safety.
mhm.
If you go through the management of change, what you do is you go through and you say, well, here's the potential impact, and then you would already build in those safeties before you make the change, because we recognize innovation keeps people in business. So
Right.
you're not confined to it and say that's it, but you have to assess what that potential innovation is going to do to any safeties that we've already agreed to after a dust hazard analysis.
Sure. So in that same vein, in that line of sustainability, so my friend Matt does his DHA. He's worked with you guys. He's talked about his future plans, and he's kind of gone through that change management process, and he's aware of that. But how can he be sure? My biggest concern is that you've limited the amount of dust building up out in the plant, but now he's put the DHA up on the shelf, and that's where all the dust is collecting on that DHA, because
Right.
he's not pulling it off regularly and taking a look at it
Right.
and going through that. So what is your recommendation on how often should they be reviewing it, and when do they take a look at it?
So from a consensus standard standpoint, and again, NFPA being progressive and establishing this, there's a revalidation that is required every 5 years, right?
Okay.
And we're in the process, and part of my road warrior journey has been doing a couple of revalidations where you go back and you look at the recommendations, you look at everything that was done 5 years ago, you look at any change management documents that were developed between the time of the initial DHA and now this 5 year review period, and then you look for any new hazards. So you have to revalidate it every 5 years. Now, in terms of putting it up on the shelf, If the DHA is done correctly, there are checks and balances built into the controls that should be audited and maintained over the life of the process. So this is that management systems element. There is a
Right.
requirement to have management review. So there should be action items that are reported on just like you would report schedule attainment, just like you would report a quality defect, just like you'd report any other safety incident. Any of the critical items identified in the DHA should be part of your reporting metrics and your monitoring. So what we try to do is we try to integrate certain requirements or continuous checks into maybe some PMs, right? So you have a PM for a dust collector. We may add one or two steps that are required for your maintenance folks to check out. Someone needs to, just like they would audit the regular PMs, make sure those things are done. So usually with companies that are in that continuous improvement space, they're measuring and monitoring OEE, overall equipment effectiveness, right? You're looking at your schedule attainment. You've got all those different metrics. So as you report those, what we try to do is integrate our solutions into what you're already monitoring and reporting with some specificity in terms of here's why you're doing this, because it's related to dust. So if you're doing the checks and balances on those, the report itself, could sit somewhere. You don't want it to just collect dust, but
Sure.
you've got enough integrated management system components that if there's a failure occurring, someone should know. So that
Hmm.
leader at the plant, that plant director, when someone comes into her or his office and says, "Hey, we're going to change line one. We're going to add this like this," the first thing should be, "Let me see the MOC, the management of change."
Hmm.
That plant leader, that plant director should sign off on all changes that occur in the plant. And what they should ask for is the technical basis for the change, that they've done the analysis of the impact of the change. At that point, again, a metric of how many MOCs submitted and approved. There are sustainable systems that you build into the process that will tell you if you are succeeding or failing in terms of your dust journey. So it becomes a living document in that it creates checkpoints, gateways, and other systems. So you shouldn't have to always go back. You could go back to it as a technical reference for the MOC, because when we write our
Right.
reports, we put a lot of different technical information and we cite code. You could go back to it for that. But in terms of your daily journey, if we've done our job correctly, it's integrated in what you do as a business.
And somebody's really got to own it, right?
Yeah,
Somebody's got to be the point person.
you
It
gotta be
can't just be the team,
right.
because in my experience, if the team owns it and the team's in charge, right? If everybody's in charge, nobody's in charge, kind of thing. So who typically do you see is the owner of the DHA and is
And
responsible for that?
here's the crazy thing about that. We see a wide range. So
Mhm.
sometimes we're called in by engineers. Sometimes
Mhm.
we're called in by EHS folks. And ironically enough, if we're called in by engineers, um, you know, we our approach, in terms of the information we get and everything, we're already with the resource that knows the capital budget, knows all of the incidents.
Right.
When we're called in by EHS folks, then we know the incident histories. We know all of so ultimately we're going to get them all together. But what we found is that it is again back to a concept of developing a RACI, right? Responsible, accountable, consultant, and informed. That point person on site, that's a question we generally ask, and it depends on culture, right? In some instances, because a lot of this is going to be capital, it's going to be equipment over some time. The engineering resource is the point person and will be the captain, for lack of a better term.
Sure. Sure.
Some organizations see it as regulatory and risk, so it falls under the EHS person. But one of the things that we do before we leave is we try to understand clearly who that point person is going to be.
Yeah.
That point person is the one that we generally have the contact with. That over the life of the process, again, trying to be the trusted advisor, we want to make sure that that point person knows that they can call us. If it's something that requires new proposals and new estimates, then we make that clear. But if it's just some general clarifications, then we do that. But it's usually in most instances it is kind of an engineering resource that serves as that point person. But we've seen engineering and EHS partner and take elements, management systems, and some risk areas for EHS, and then all of the equipment reviews and things like that with engineering.
Got it. Yeah, that makes sense to me. All right. So I'm going to get with Matt and I'm going to tell him to test his dust.
Yep.
Number one, to get a starting point, get a baseline, understand what he's really working with, and go from there. And then start down the DHA path.
Right.
And giving you guys a call and getting started with the DHA to look at, and really it's the 5 elements of the fuel or the combustible dust pentagon, looking at fuel, ignition, dispersion, and confinement and oxygen, and trying to eliminate those pieces through that DHA process of understanding what's going on in his facility, where the risks are, and creating a roadmap, not that has to be executed today, but that can be done over time, and start planning for that and taking care of the big risks first. So again, I love what you talked about, creating a path that's safe, sustainable, and affordable. So how do they get in touch with you and DEKRA, and how do they get started on that journey?
Yeah, so there are a couple of resources available to you for DEKRA. You can go on our website, DEKRA.com, DEKRA North America. You can reach me directly at 609-285-9244 or kevin.jeffries@dekra.com via email. We'll direct you to the right resources. We are the process safety division, so we are the group that handles your process hazard analyses and your dust hazard analyses. But again, the DEKRA.com, DEKRA North America websites, and you can get to us from there.
Excellent. All right. Thank you so much for your time today and sharing your expertise. I've enjoyed this, probably a little too much talking about just dust and combustible dust. So thank you so much. It's been an honor and a pleasure to have you on today. If you out there watching us today have enjoyed the content and appreciate what we're doing, go follow us on LinkedIn, give us a thumbs up, and follow us on YouTube. Subscribe to our channel. Thanks so much for watching. I'm Jordan with Sonic Air. Have a great day.